Hi students, today's topic is backtracking. Backtracking is one of the problem solving strategy or one of the problem solving technique. Backtracking follows the brute force approach. Therefore, in this lecture, I am going to explain you about what is backtracking, what are its applications, and some complex problems like n-queen problem, sum of subset. These problems we will solve by using this backtracking technique. Before that, let us see the definition and then we shall try to understand the backtracking by using a simple example. Now, backtracking is nothing but is a general algorithmic technique that tries to build a solution incrementally, one piece at a time, and removes those solutions that fail to satisfy the constraints of the problem. The simple backtracking technique is nothing but we will use in Sudoku solver and word puzzle game. These are all nothing but where we apply backtracking. Like generally when you go for robot path planning, or like for example you want to reach to any city, you will try one possibility, and suppose if you couldn't able to find out that, then you will come back and go for another possibility, and then you try in that route. If you get your destination, no problem. If suppose you get any dead end and you couldn't find the place to where you want to go, again you will come back and go and try for another possibility. Like that, this is nothing but if you want a solution, you are trying all the possibilities, and any constraint satisfies our solution. That means any possibility which satisfies a constraint, then that is nothing but our solution. Therefore, here when you compare to the dynamic programming we have only single optimal solution. Okay, suppose we have some set of solutions like S1, S2, S3. Out of these solutions in dynamic programming, we will have only one optimal solution. But when you compare to the backtracking, we may get two or more optimal solutions. Okay, like S1, S2, S3. If suppose constraint satisfies, then we may get one or two or more solutions. Therefore, this is the difference between dynamic programming and the backtracking. And this backtracking we can clearly understand by using a state space tree. We will depict the possibilities. We will just clearly show all the possibilities and understand the backtracking strategy by using a state space tree. And backtracking is in real time. We apply backtracking in various places and various applications. Route navigation and pathfinding, we will apply the backtracking, and the job sequencing and resource allocations, cyber security and password cracking. In real time scenarios, real world applications, we will apply the backtracking concepts here. In route navigation and pathfinding, backtracking helps when trying alternative routes in a city or warehouse if the initial path is blocked or suboptimal. And cyber security and password cracking, here in this we will try all the possibilities, like we will try all capital alphabets and some special characters, Usually when you talk about the passwords, the password should be of 8 characters. Its size should be greater than 8 characters or within 8 characters or 6 characters, like that. Some password constraints are there, and based on that they will try all the possibilities and find a set of solutions. Okay, therefore this is one thing. And when you go for the job scheduling and resource allocation, if you concentrate on factories, hospitals, or cloud computing, allocation of limited resources to different people efficiently, this is also one of the backtracking application. Therefore, these are all nothing but the real world applications where we implement the backtracking concept. Now, let us still understand the backtracking by using or by taking one simple example, and then we shall go for the complex problems where we will use the backtracking. Now, the example is like, for example, we have 3 students, 2 boys and 3 girls. Let us consider we have 3 students, and that are 2 boys and 1 girl, right. Now, what we have to do? We have to arrange these 3 members in on, or we need to make them sit on 3 chairs. Okay, 1 chair, 1 student, 1 chair, 1 student. How many students we have? 3 students we have, right. Therefore, these 3 students we need to make them to sit on 3 chairs, 1 chair, 1 student. Therefore, you have to write all the possibilities, right. Then first of all, I will explain you what are the different possibilities we will get, and then I will say the condition. Okay, why we are applying here condition? Therefore, we need to get one solution out of all those possibilities. Now, that condition we will call it as a bounded function. Okay. Now, in order to do this problem, I am using the state space tree and try to explain this example. Now, as I said that I need to place, or I need to make these 3 students sit on these 3 chairs. Let us consider the this is chairs, these are chairs, this is first chair, second chair and the third chair. Now, what is the first possibility? The first possibility is B1, B2 and G1. Let us consider, let us imagine this is one possibility. That means first chair boy 1 will sit, second chair boy 2 will sit, and third chair girl 1 will sit, right. Therefore, let us draw one state space tree for this. Now, this is nothing but one slot. I can consider it as one slot, and this slot, that means one chair, this is for boy 1, next one is for boy 2, and another one is for girl 1. This is nothing but one possibility, right. Okay. Now, let us go for the another possibility. Now, how you will go for another possibility? You need to backtrack from the bottom to top, right. Therefore, this is nothing but our backtracking. Therefore, this is a depth first concept. Okay, depth first. First, we will go deep into the tree, then we will come back, we will traverse it from bottom to top approach. Okay. Now, what I will do? Now, another possibility means I'll come from the last, right. Now, what are the other possibility? Just I can change 2 values, like B1, boy 2 should given the third chair, and girl should we should give the second chair. Therefore, here girl will be giving the second chair, and boy we are giving the third chair. Boy 2 is giving the third chair. This is one possibility, this is the second possibility, right. Still, do we have any other possibilities? No, we don't have any possibilities, right. Now what we have to, as we have no possibilities, next what we have to do, we need to even change the first chair also. Therefore now what I am doing, first in the first chair, first time I am making boy 1 to sit, next time I have a chance of making boy 2 to sit, right. Now when boy 2 has sit in first chair, then in the second chair there are two possibilities. I may make boy 1 to sit, or I may make the girl 1 to sit, yes or not. And in the third chair, if boy 2 is sitting in the first chair, boy 1 is sitting in the second chair, the third chair obviously girl 1. Okay, similarly, if the first chair boy 2 is sitting, second chair girl 1 is sitting, and the third chair nothing but boy 1. Therefore, this is another two possibilities, right. Like that, if you go on backtracking, and then if you go on, you will try many number of possible solutions. Now see here, first chair boy 1's turn is finished, first chair boy 2 turn is finished, next the other possibility is the girl, right. Therefore I am making the girl to sit in the first chair, right. Now when the girl is in the first chair, the second chair we may expect boy 2 or boy 1. And if you go this possibility, the third chair is nothing but boy 1. Suppose if you try this possibility, the third chair is nothing but boy 2. Therefore these are all nothing but what, different possibilities, different possible solutions. The thing is, we are making the three students sitting in or sitting on three chairs. We are making three students to sit on three chairs. Okay. Therefore this is one possibility. I can make the boy 1 sit in first chair, and boy 2 second chair, and girl 1 on third chair. Okay. Similarly, boy 1 girl 1 boy 2, boy 2 boy 1 girl 1, like that, all different possibilities. Total how many possibilities I got? 1 2 3 4 5 6 possibilities, right. Now out of these 6 possibilities, what is our solution? Therefore how you will decide that this is a solution? Therefore we have to keep a constraint. This constraint we will call it as bounded function. This constraint we will call it as bounded function. Now what is our bounded function here? The bounded function is the girl should not be in the middle. The girls should not come in the middle. This is our constraint. The girl should not come in the middle, right. Come in the middle means the girl should not be between two boys. Okay. Therefore here the girl should not be in between two boys means, if that constraint, any solution satisfies, any possibility satisfies, then that is the solution. Okay. If any possibility satisfies this constraint, then that is the solution. Now let us check it. First possibility, B1 B2 B1 B2 G1. Therefore is girl is coming in middle? No. That means this is one solution set, right. Next try for another possibility, B1 G1 B2. Therefore it is coming in the middle. That means girl, as we have three students, girl should not come in middle means girl should not be placed in the second position. That means we should not make girl to sit in the second chair. Now here who is on the second chair? Girl is on the second chair. That means this is nothing but, this process is killed. Okay. This process is killed. Okay. Therefore this is not a proper solution. Similarly, when you go for another approach, boy 2, boy 1, girl 1, therefore this is our another solution. Boy 2, girl 1, boy 1, therefore here also the second position is girl, therefore this is also killed. Girl 1, boy 2, boy 1, this is one solution. Girl 1, boy 1, boy 2, this is one solution. Therefore total 4 solutions we got. Total 4 solutions we got, right? Therefore this is nothing but the backtracking, right? Actually I have drawn the complete space state tree in order to make you understand how many possibilities we will get, and how to check the constraint and how to kill the process. But when you are constructing the space state tree, first you have to keep the constraint in the mind, and then you have to construct the tree. Okay. Now any possibility, if it is while you are building the space state tree, any possibility if it is not satisfying the function, okay, then you have to kill the process there itself. Further, no need to add the another possibility or another component, right? Therefore this is the example of backtracking. I hope you understood this one. Now in the next we shall see some complex applications where we will apply the concept of backtracking.